Remember that we were just looking at the basic anatomy of a program, right? And before we do that, I just wanted to share these notes with you that I didn't write during the class, but I wrote up, these are the things that we talked about during the class. So remember that we are on the live stream, so if you have questions, you can post there, or just raise your hand here, right? So remember that the purpose of comments are for humans, right? That's the audience that you're going for, so it should be plain English, and it should be explaining the what and the why, not necessarily the how, right? Instead, generally code should be self-documenting, right? That lines of comments like this prompt the user for input, that's superfluous cruft. That should not be there, because anybody that has had a little bit of C, or eventually Java when we look at that version, knows that the printf statement prints a message to the standard output. They know that the double quotes is going to be a string that contains the message, et cetera, et cetera. So code should be self-documenting. But when you do put in comments, you can use single-line comments with // // multi-line comments are going to be / star, and then end with a star // and then doc-style comments. Again, if you get into the habit of writing doc-style comments, right? For example, here. Let me go ahead and put it onto the main. Oops, it didn't work. Oh, I'm not in. That's where I wanted to be, right? It looks like I already did it here, right? Remember that all I had to do was type this first part, hit enter, and then it formatted it all for me, right? And even put stuff in like, like C Burke here, okay? Let's see. All right, this is a C thing now. Preprocessor directives begin with a hash. We talked about all this, right? I've got 3 classes, and I don't necessarily remember where we picked up last time. So I'd have to rewatch the videos, right? But you can include external libraries using hash include, right? And for example, you can bring in the math library eventually when you need to do some math stuff like sine, cosine, tangent, square root, and stuff like that. Absolute value. Define is a macro. It basically provides a cut and paste name, a replacement for these mysterious magic numbers, right? 1.60934, what is that? Well, that's the number of kilometers per mile. A human readable label for that thing instead of this magic number. Right? The equivalent in Java was to define a variable that could not be changed using this final keyword, right? We made it final so that you cannot change it later on, so that kms per mile now is, I don't know, 5, right? That's going to be a compiler error. It's not going to let you change that because you said that that variable value was final, right? You made it into a non-variable variable, right? Something that's not, that can't, what's the opposite of a variable? Something that a variable is something that can vary. What's something that can't vary? Constant, right? This is a constant, okay? Macros make your code more readable and maintainable. Don't use magic numbers in general. And then we also talked about the entry point of any program is going to be its main. Over here in C, we have a main that looks like this. Over here in Java, we have a virtually identical main that looks like this. Instead, we use public static void main, and then we provide arguments as args as that's an array. In fact, guess what this is? argv. It's an array, right? It's an array of strings, right? It's actually a 2-dimensional array of characters, right? So think about it in terms of the first row is the first string, right? First sequence of characters. The second row is the second sequence of characters, the third row, et cetera. So it's actually 2-dimensional, right? And each individual cell is a character. Yeah?
Are the asterisks necessary when making an array?
Yep. Well, for now, yes. There are subtleties where you can use square brackets instead, but we're not gonna. Right? These are pointers. These are memory addresses of where that thing is stored. Over here in Java, we don't have such access to low-level memory. We don't have pointers. Right? Okay. One thing that we didn't necessarily talk about was, was other punctuation, right? Semicolons and executable statements, just like periods and the sentence in writing, right? You have to know that this is an idea, this is the next idea, this is the next idea. If you didn't have punctuation like that, it would be very, very difficult to read, right? It would be very, very difficult for a compiler to figure out what you're talking about if it didn't have its own punctuation. Curly brackets, opening and closing, denote code blocks, right? The class itself here in Java is opened with a curly bracket right here, and then closed with a corresponding curly bracket down here. Likewise, in both programs, we've got our main beginning with an opening curly bracket and ending with a closing curly bracket down here. So if characters form words, words form sentences, what do sentences form? Paragraphs, right? These are our paragraphs in code, basically, right? That we've got these chunks of code, which we call, where is it? Blocks of code, right? Instead of paragraphs of code. Parentheses denote functions or grouping of things, right? We put parentheses around, for example, the parameters of this function, which we'll talk about later. We put parentheses around the things that we want to pass into print or printf so that it actually prints. The equivalent over here in C is going to be printf, and then not only do I want you to print out this statement here, but also replace these placeholders that we'll talk about here shortly with the values stored in miles and kilometers respectively. Right? So how did I denote each one of those things? Here's one thing, and another thing. I want cake, ice cream, and milk, let's say, right? What separates those in plain English? Commas. And what separates them in code? Commas. Lists of things are denoted with commas. Right? Double quotes denote strings in both languages. Right? Single quotes do not, in both languages, indicate single characters. The capital A, the lowercase c, something like that. But double quotes are an entire sequence of characters, and you can't use them interchangeably. There are some languages, if you've got a Python background, right, you can use them interchangeably. PHP, JavaScript, right, those are all, you can use them all interchangeably, as long as you're consistent about it. If you open it up with a double quote, you have to close it with a double quote. If you open it up with a single quote, you have to close it with a single quote. Right? White space helps make your code more readable, right? Now, if you were writing that English paper, would you not put any spaces between the words? Right? Would you not put any vertical spacing between lines? No, right? It would be completely unreadable. Now, certainly we have spacing here, right? The horizontal spacing, right? The first version looked better than that, right? Because scrunching that all together, yeah, you save space, but it's not very readable, is it? Right? So definitely space things out as necessary. But also, what did I do here in the main? Right? I indented. Right? And I made sure that everything in the main was indented at the same level. Likewise, over here in Java, I did the same thing. I've got my class, and then I've got things inside my class, and I indented those. But things inside those functions or methods, I indented those further, right? Indent, indent, indent. Think about a bullet-pointed list. Here are the first three ideas of your bullet-pointed list. Here's a sublist. Do you put the sublist at the same indentation level? Nope, you go over. Sublist, sublist, sublist. And then you return back to the outer list here because you've got more stuff to put in your bullet-pointed list, and you continue at the same indentation level. Same thing with both languages, right? White space definitely matters more to humans, right? It makes your code more readable and thus more maintainable and more understandable. Now, over here in this IDE, what did I choose to do? I chose 2 spaces as my indentation, right? Some alternatives would be, I want a tab over instead, or say 3 indentations. Or if you want to be a real mad lad or whatever, 4 spaces for your indentations, right? No indentation, bad. 1 space indentation, that's not very offsettable, right? But 2, that's why I use just 2. It's just, it's easier on typing. It doesn't really matter what you choose because you need to be consistent about it. That's what we're going to be looking for. You shouldn't indent 5 spaces here and then a tab instead over here. You need to make sure that you're doing the same thing all over the place, right? So what happens when you get yourself into a mess? Again, white space doesn't matter to the computer. You can put everything on the same line. In fact, if you are in a programming language like JavaScript, sometimes you want to do that. You want to write clean code, clean, beautiful code, but ultimately what you're going to do, JavaScript is not a compiled language, So when JavaScript makes it over to somebody's web browser to be executed, that's all that code is being sent plain over the network, right? Including all the white space. Why are you sending white space that ultimately gets ignored at the other end? So what they have are compactifiers or uglifiers that intentionally take JavaScript code and take out all the unnecessary white space, replace your nice variable names with smaller variable names like A, B, C, D, because it doesn't matter to the compiler. It only matters to the humans that have to read your code. And then it compactifies it and then sends it over the wire so that it's not wasting bytes on the network, right? You don't want to do that like, with code like this. So what happens when you get yourself into a screwed up beyond all recognition kind of thing here? Well, you can go back and fix it, right? Or you can go back in time and write it correctly from the start, right? That's the ideal. Just get into that habit of writing good code up front. But if you ever do, like you inherited code from somebody else and it is ugly, right? All right, A style, miles to kilometers, .c. Let me close this and open it back up because it's not good about reloading stuff. Oh, nice, right? It fixed all my, my bad stuff for me, right? It's not that sophisticated, right? It will fix mostly white space. It will not necessarily fix, vertical white space. For example, it did not restore that empty horizontal white space right there, right? Maybe I don't want it there though, right? It's not going to make that judgment call. Over here, that was A style from the command line. What about over here in Java? There we go. Put all those things on the same line. Ugly, ugly, ugly. There we go. Ugly, ugly Java. Right? So there's no A style here, instead it's a quick key. Right? So for those of you following along at home, Shift Command F on Macs. Don't ask me what it is on Windows. Yeah, thank you.
Control A, Control I.
Control A, Control I? Okay, there should be just one quick key, isn't there? I don't know.
That's how I always
All right. Anyway, it restores it. And the same thing, it's not that sophisticated. If you wanted vertical or horizontal spacing like that, then you need to do it, right? Okay, I'll leave it like that for now. But otherwise, tools, and they're online tools, by the way. For example, some people, especially in C, like to go old school and put the opening curly bracket on the next line at the same indentation level. That's very, very old school C. I don't like that because this is the modern convention, right? If you want to follow that old convention, that's perfectly fine. Just be consistent, right? And if you want to, in Canvas, we provided a website. It's called a C format. It's actually just a code formatter. What you can do is you can look down and reformat your code in a variety of style guides. Because ultimately, it doesn't matter what your personal style is. Eventually, when you go and get a job, they might have a style guide that they want you to follow so that all their code among their 100 developers is all consistent. There are GNU style guides. There are style guides from Google. There are style guides from Mozilla and stuff like that. And you can take your code and you can reformat it in any one of those style guides. Right? Don't get married to a style. Right? Find something that works for you and go with it and just be consistent. But understand that eventually you might have to conform to somebody else's style, somebody else's ugly style. Right? Anyway, there we go. A style, above all, should be consistent. Right? And of course, their blocks of code should all be indented at the same level. That's almost a universal. And there are some reserved words in the anatomy of our program. For now, int, double, return, those are not things those are things that are built into the language that you cannot use, say, as variable names or as function names. Okay? All right, so where are we now? What's the next thing in this main here? Printf and scanf, okay? And we've got another printf down here. So let's talk a little bit about input and output. Input, output. Sorry, I need to be on that one right there. And let me give myself some more room. There we go. All right. So what about in C? Right? So how do we do output in C? What function is over there that you can see? Is done with printf, right? You can provide any formatted string and it will print to the standard output. The standard output, we're not doing graphical user interface program, maybe much later on, but it's not going to be a focus of this course. And so you're used to end consumer products, right? Your phones, your games, and your websites and stuff like that, right? The vast majority of actual computer software is not meant for end consumer consumption. So when you think of output and input in the context of your phone, you think a big shiny button that you can tap as input. You think of a text box that you can write into and edit and stuff like that. You think of output as being a message that's displayed or a notification that comes up or something like that. As far as we're concerned though, the output is going to be output in the terminal or console. Right? That's what we mean by standard output. Okay. Input in C is done with scanf. Scanf is just the opposite. I mean, it's reading something in. For both, you use placeholders. Placeholders to indicate a variable should be the type of variable. Indicate the type of variable that should be input or output. Right? And for now, we're just going to look at the three simple ones. %d is for integers, right? Whole numbers, right? Ints in both languages. We'll talk about actual variables here momentarily. %f is for floating point numbers, right? In other words, we mean doubles, right? Double, there we go, for printing, right? %lf is for doubles, there we go, when using scanf. Right? So unfortunately, there is a little bit of a difference between printf and scanf. Let me go ahead and increase the size. Is that big enough for everybody in the back now? Good? Okay. All right. You do have to use %f for one and %lf for another. And if you forget, the compiler will warn you about it, and then you can go and look at it a little bit more closely and say, what did I actually mean to do there? Okay. And then finally, if you have a single character, %c, that's the only one that makes sense, right? Is for single characters. Right? Like chars. Right? So %d, that doesn't make sense because we want to read an integer. It should be %i, right? That's reserved for something else. D is short for decimal, or not decimal, digit, I think, digital or something. %f is short for floating point number instead of %d, right? So %d is not for doubles. It should be because %i should be for integers, right? But that's not how it works. And %lf is for long floating point numbers. So I'm not going to go over it, but there is another type of variable here. Say float x is equal to 3.14. Right? So both languages support what are called floats. Floats are simply less accurate doubles. And so I'm only going to introduce doubles here. Right? If you want to use floats, fine. You might get less accurate results that don't match the grader when you go in and use it. Right? The only time that you really want to use floats is when the precision doesn't matter, one, and two, the efficiency matters more than the precision. For example, game development. We use Unity in our VR course. And Unity, by default, uses all floats for everything because floats are accurate enough to compute any geometry down to a single pixel on your screen. They don't need to be more accurate, right? Because you can't get more accurate than a pixel. But they're also shorter and therefore faster because they're only 32 bits. Right? But we're not going to use that in this class. Okay? So take a look at how we use them over here in the C program. Right? %lf here, I used it for scanf because I wanted to read in miles. Right? So another observation, and just this is a gotcha, right? When using scanf to read in a variable, always use the ampersand. Right? percent ampersand right there. Okay. Oh, sorry, I should have had that. There you go. Just for now, understand it's required. The reason that it's required is because it is actually getting the memory address of that variable so that it can pass it by reference. We'll get into that when we get into pointers, when we get into functions and stuff like that. If you don't do that, the compiler will complain, right? Miles to kilometers.c, right? That it doesn't match %lf does not match the type because it expects this double star instead of you gave it a double, right? And so it's just a reminder to yourself to make sure to go back and put that ampersand in there and worry about it later. But when I use printf and I use %f to print something, I do not use an ampersand. I just give it the variable because those are passed by value. We'll look at that later, right? If you have multiple placeholders, you should generally don't want to do multiple placeholders in scanf. We'll very quickly in this course abandon scanf anyway. This is just to get you started. But printf, if you have multiple things that you want to print in one line, you can use multiple placeholders, %, right? The order matters. So the first % sign will match the first variable over here. The second placeholder will match the second variable over here. If I add three placeholders, 3 variables. If you have 2 placeholders and only 1 variable, the compiler will warn you about that, right? If you have, if you have 2 placeholders and 3 variables, the compiler will probably warn you about that. Too many arguments, too few arguments, too many arguments, right? Pay attention to what the compiler is telling you. How do you read this message? Miles to kilometers.c. There was a problem on line 23 starting at character 12. Immediately go to that line 23, character 12, right? We don't have a character counter here, but it displays it right here. There's something wrong here. Here's the message, right? It won't always be that easy, right? Some of these messages can be very, very cryptic and difficult to decipher, right? But at least it sends you on the right track. What about if I screw up over here in Java? It really tells me about it, right? It underlines it with a red line here, right? It won't compile. But it also gives me warnings. What kind of line do you see now? If you squint really hard, that's a yellow line, right? If you hover over it, it tells you what the warning is about. The value of the local variable kilometers is never used, right? An unused variable is a code smell, right? Smell, right? It's not necessarily bad, it just stinks. Maybe it is bad, right? Those are called code smells. And you want to make sure that you're taking care of them. We'll take care of this here in a moment because we need to translate the rest of this program, right? In fact, do we want to do that? Let's do it, since we're talking about output. I'm already reading in the next double, right? I'm already reading in the number of miles. Now how do I compute kilometers is equal to kilometers per mile times miles that I read in? Guess what? It's exactly the same. There's no difference. This is, well, I named my variable differently. There we go. Okay. In fact, here, let me show you a trick. Maybe I did go KMS, all right? And I regret that now, right? I'm not paying by the character, right? I want to change that one variable name. Change it here, change it here. If I use it in 50 other places, change it in 50 other places. Or double click it, right click, refactor, rename, kilometers. There we go. Every reference to that variable is now changed. Right? Do you know all these tricks already? No? Okay. So this is valuable? Right. Eventually it'll be valuable when you have to change 50 things and you don't want to sit there type. Right? Okay. So what about printing stuff? Well, we could go system.out.println, right? Println. And for those of you with a Java background, you might have been doing this all your entire life of miles plus miles is plus kilometers plus, what was the rest of the message? Is equal to. miles is equal to, and then you have to nicely format this, make sure that there's a space there, kilometers, right? Period. And then it's already println, so it'll put that next line for me. And this will work, right? If I run this and enter 100 miles, right? Great, 160 kilometers, right? But guess what? If you want a more compact way of doing it, system.out.print f, so you still have to do system.out, but otherwise it's exactly the same. Right? Every single placeholder that I just gave you is going to work in Java as well, as long as you're using the printf over here. And, oops, kilometers, there we go. 100, there, done. Yeah.
So is that recommended, or is that more of a?
It's up to you. If you get used to printf style printing, you never want to go back because it aligns everything up. But then at the same time, the vast amount of code that you'll, long term, the vast amount of code that you'll eventually write won't have any output at all, right? 99%, there's a quote, 99% of software is designed to interface with other software, not humans, right? So why are you printing anything, right? The computer doesn't care that you're printing something. The computer's not reading it, right? If you're printing output, you're producing output as an input to another program or to another function, then yeah, you're printing in that sense, but not in a human readable format, right? This is intended for humans to read, right? All right, so there is input, output. Some style items. Right? Actually, no. Let's talk about variables first, because we need to define variables, and that's what we'll do for the rest of the day here. So, first of all, both languages support a lot of different variable types. I'm going to keep it simple and keep us bound to those three to start out. Right? The first one that we have are integers. Right? The second ones that we have are doubles, and the third one that we're going to look at are characters, right? So first of all, an int is an integer, right? Our integers, right? Whole numbers, both negative, positive, 0, right? But integers are only 32-bit signed 2's complement integers. Now, don't worry about what that means. When you get to computer architecture, you'll learn how to count in binary. You'll learn how to use 2's complement to make it efficient for circuits and stuff like that. Who cares, right? The takeaway here is that there is a limit. If you can only have a certain number of places to express a digit, for example, if I said you only have 3 digits, right? Or let's use years. You only have 4 digits to express the year, right? Can you express the year 10,000? Right? What's the maximum year that you could express, that you could represent? 9,999, right? And if I only gave you 2 digits, right? Most of you are probably born after the millennium, right? But before the pre-millennium, right? The computers, many computers did only give you 2 digits to express the year. 1984, right? 1999. What happens when we get to the year 2000? We can't express, now it goes to 00, and what year is it actually? 1900, right? So, if I give you a restriction on the number of digits or the number of bidgets, we call those bits, right? Then you have some restrictions, right? You can only express, at most, 2.147 billion, right? I'm going to put this in the yeah, is math mode working there? Yes, it is. Good. Right? And when I push it to GitHub, finally it will work. After 10 years, they finally have LaTeX support in their Markdown, and it only took them 10 years to do it. When you see this on GitHub, it will render that math there, the 2 to the 31st, correctly. Right? So you've got some limitations here. The least number that you can express is negative 2.147 billion and change. The greatest positive number that you can express using an integer is 2.147 billion and one less. You'll note here that the other one goes to 48, but that one goes to 47. Why? You got to start, what about 0, right? 0 is taking up that other one, right? The way that you should think about this is not the number line. The number line is infinite. If I have 0 here, I have negatives that going out this way, infinite. I have positives going out this way, infinite, right? I can go as far as I want, but I can't do that with a finite representation. I've got to stop somewhere. So I stop at negative 2.147 billion, positive 2.147 billion, and then it's not a line anymore. It becomes a circle, right? So what happens, let me go over here, right, and suppose that my miles, actually I want an integer here, int number of students, right, is equal to, say, that very large value there, right? That's the maximum value that I can express. Printf, number of students, is equal to, what's my placeholder for an integer again, if I want to print out the number of students? Percent %d. All right, and I'll end the line so that it's nice and pretty. I'm going to try to add one more. Number of students is equal to number of students plus 1. That's one way of doing it, okay? What are you complaining about? Sorry, I'm in Eclipse. I meant to be over here. There we go. Bad alignment. What should I do? Run a style. I'll do that later. GCC miles 2 kilometers dot C. Right. Wait. GCC. Oh, I did 2 periods. Sorry. All right. Actually, I want to print it out afterwards. All right. So take out your math hats and tell me what is 2.147 billion, 483,647 plus 1. Blah, 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 blah. 48, right? Is it? Let's run it. Nope. What happened? Does that number look familiar? That's the minimum that you can represent. That's called overflow, right? So one way to imagine that is a cup, right? A cup can only hold so much. Our integers can only hold so much. And if you pour it to the top and fill it up, it's full. If you keep filling it, what happens? It overflows. The better way of thinking about it is that number line that has been cut off because it's finite, and then you wrap it around. And now it's a circle that you're going around in circles on, right? So I'm going to go ahead and add, I start at 0. I add 10, 20, 30, 40, 50, until I get to the maximum value that you can express. 2.147 billion, blah, 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 47. And I add one more. What have I done? I've gone on to the negative side, right? And I'm coming back to 0 eventually by adding too much, right? So that's how numbers actually work in a computer. What if you need to express something that is larger than 2.147 billion? You're bringing in a library to do it, for C and for Java. For C, it would be the GMP or GNU multi-precision library. For Java, there's something that's almost built in called big integer, right? Foo. There we go. And where is it stored? I think in java.math, right? So in the math library, java.math, there's this thing called big integer, and it can grow as much as you want, right? It can be as arbitrarily big, but you're paying for it. It's way less efficient, right? It can no longer run on your processor. It has to run in software, right? So we will not have need of much beyond 2.147 billion. But doubles also still have a limitation, right? It is a 64-bit floating point number, right? 64-bit IEEE 754 floating point number. Don't worry about that, right? If you actually wanted to read the standard, you'd be reading 200 pages of a technical manual on how this actually works in any computer that is compliant with that standard, right? The takeaway is that you have about 16 to 17 digits of accuracy, right? You cannot express beyond that, right? So for example, pi, you can express it out to 17 decimals of accuracy, 16 decimals of accuracy. But if you try to express pi beyond that, you're going to get garbage results, right? If you take pi and multiply it by 100 billion, right? That's fine. All it's doing is moving that decimal point over, right? And you will still have 17 digits of accuracy. Very, very large number, much larger than 2.147 billion, but still expressible with 17 digits of accuracy, 17 significant figures of accuracy. Right? And the reason for that is that in a computer, computers essentially use scientific notation for representing floating point numbers. Right? So for example, if I have 3.14159, right, times, oops, 10 to the, I don't know, 10th, right? That's not, let's get a different number, 5, right? There we go. So that's not actually pi, is it? What is that? Pi times 100,000? Please help me. Okay, good. That's pi times 100,000. So what are you doing when you're multiplying by 100,000 in base 10? Or you're multiplying by 10 in base 10. You're just moving the number over. Huh? It's kind of like it's on top of the water and it's bobbing over here. Right? It's floating. That's why they call them floating point numbers. The decimal will float left or right depending on the magnitude of the number that you're doing. Right? Now, there's a name for this, right? This 5 up here, that's called a what? It's an exponent, right? There's also another bit out here representing either positive, implicitly it's positive here. If it's negative, then that bit will get flipped to 1, right? But also there is this thing, I don't know, when you learn scientific notation, do you learn a name for this thing right here? This is out front there's a sign, up here there's an exponent, but what's this thing called? No special name? In computer science we call it the mantissa. Again, just a preview of computer architecture later on, right? The takeaway from all of this, you can ignore it all for now if you want to and wait until your higher engineering courses or whatever. The takeaway is that you only have 16 digits of accuracy, right? For example, what if I tried to express double foo is equal to 1.0 divided by 3.0, right? And I tried to print it out, printf. Foo is equal to percent f, end line, foo. So you tell me, what is 1 divided by 3? Let's kill this program. Put on your math hats, first of all. It's going to be 0.333, and then what do you do over it in the grade school way? The line. Why? Because it repeats forever. Okay, it looks like it. But remember, we only have, say, 15 digits of accuracy. What I'm going to do is here, I'm going to go out to 10 digits. I'm going to print 10 digits of accuracy. Right. Still 33333. Let's go out to 20. Remember, it only has about 17 digits of accuracy. What happens when I get out far enough? It ain't 3333 anymore. It is garbage. Right? Garbage that you can't rely on anymore. Right? So you can, I don't know, the eagle-eyed out there could count up those numbers there and tell me how many there are. There should be like 16 or 17 there. Okay. For that reason, 1/3 plus 1/3 plus 1/3. In math, that would be 1. It ain't 1 in computer science, right? Because 0.333333 and then garbage plus 0.333333 and then garbage, 0.333333 garbage is maybe 0.9999999 and then garbage, or it might be that garbage might end up getting you up to 1, over 1, right? Let's try it. Double bar is equal to foo plus foo plus foo. And I'm crossing my fingers here and hoping that the compiler doesn't optimize that away and say, what are you doing, right? Why are you doing that? I'm just going to replace it with 1. Yeah, okay. It's optimizing it away. It made me a liar because, how do I shut off optimization? GCC no optimization. Spell it correctly. How to disable optimization. Good Stack Overflow. 0. I don't even know if this will work. Nope, it didn't. Okay. It's still optimizing that away somehow, right? But anyway, limitations. Why? Because a computer is a finite thing. It only holds so much memory. If you paid for if you paid for 8 gigs of RAM, right, you got 8 gigs of RAM. You don't have infinite RAM, right? You don't have infinite memory that you can express these things, right? A character is a single character, ASCII, for C, a single ASCII character. Right? So what is ASCII? And for Java, it's going to be a Unicode character, a single Unicode character. Right? So let's go to ASCIItable.com, ASCIItable.com. And this is what the ASCII is, right? ASCII stands for American Standard Code for Information Interchange. It's only 128 characters, and it is very American-centric. Why? Well, it's in the name, right? It's going to be English-centric because it was made by I believe, the U.S. military or the federal government at least, during the Eisenhower administration. So it predates modern computers by quite a lot. That's because the QWERTY keyboard is, 150 years, 200 years older than any computer, right? Something like that. And all they needed to do was, we've got these things on our keyboards, we need a way of organizing them. So all they did was they organized all the standard characters, put them in a table, and gave them numbers. For example, zoom in here, capital A is represented by 65. Lowercase k is represented by 107, right? And it goes up to 127 because you start at 0. Right? There are only 128 characters here. There is an extended ASCII code that was added later on that added all these symbols on there. Greek, and these other, these are called diacritics, right? The umlaut on the top, they're collectively known as diacritics. The carets, the accents and stuff like that. So they added those later on. But of course, at some point, the people realized, wait, not everybody that uses computers is an English speaker, right? And so eventually they introduced Unicode, right? And the Unicode standard is much larger. It has support for millions upon millions of characters. You can find ancient Egyptian hieroglyphics in this character set. More recently, you have emojis, right? And those are part of the Unicode standard now, for better or worse, right? There we go. There's a nice one. Right? And it has this Unicode character of it's all hexadecimal, 1F609, right? Wink, wink face, or winky face, right? Now, the takeaway here is that characters in both languages represent either a single ASCII text character or a single Unicode character. C does not support Unicode by default. So you wouldn't be able to say print this winky winky up here. Let me go ahead and get rid of all this. And let's go ahead and say printf hello. There. And let's end the line. I can cut and paste it because my browser is smart enough, right? But is this going to compile? God, I hope not. Right. Okay, it does. It ain't going to print. Oh, okay. I've proven myself a liar already. Okay, it does. All right, so that is probably the particular setup of VS Code, having a modern thinking way of thinking. This will definitely work in Java over here, as long as my thing has been set up, system.out.printf. Oops, yep. And then get rid of that white space there. That will definitely run. Yep, because Java supports Unicode characters here. But you can, in Java, oops, that's not what I want. have a variable named the winky face. 10.5, right? Okay, you can do this in Java, but I've not set up my clips to support this, and neither should you, right? You should not have variables named after Unicode smiley emoji winky winky characters here, right? Apparently you can print them both though. Int is equal to 42. Hopefully this does not compile now. Oh, it does, all right. All right, let's print this out. Print f winky face is equal to, and then we'll print it as a number, winky face. Oh my God, I can't believe that they put this into VS Code. There we go. All right, we have crossed over into truly modern computing here, where it is actually supported by whatever this is doing under the hood. Right? This is not something you should do. You need to go ahead and play around with it all you want, right? But don't submit your code like this. The web grader certainly will not support something like this. Right? That's weird. Right? I mean, even if you go to like, I don't know, like a foreign country, Japan, or where their native language is not even a part of the ASCII text characters, guess what they do? They program using the traditional ASCII text values. Right? They don't write in their own native scripts. Right? They generally. Right? Okay. So another thing about variables is that in both languages, and here's where we'll end it, in both languages, variables must be declared before they can be used, and they must be in scope, right, to use them. So for example, let me get rid of this stuff. There we go. I can use KMS per mile here because I declared it up here. The scope of this variable, it lives within this class, right? Because it's declared up here, this is where it lives, right? This entire thing. I can use kilometers and miles here, and they exist as of line 19 and for the remainder of that block of code. But if I tried to print them before I actually declared them, print system.out.println, I'll just go miles here. Right? That's not going to work, right? Look, just scope it down. This is literally what scope means, right? You're looking through a scope. Can you see everything? No, you can only see what's in your scope, right? So you're limiting your view. Now limit your view to line 19 and above. Do you see anything miles there? Nope, it's not within scope. You have to declare it before you can use it. After you've declared it, certainly you can use it down here. It's still going to complain, but for different reasons. The different reasons here being that it was never actually assigned a value, so it doesn't know what to print. But if you assign it a value, then it goes away. Right? That's a difference between C and Java that we'll rehash on Monday. Likewise, over here in C, you can't do the same thing, right? If I said up here that miles is equal to %d and print out miles, this will not compile either, right? Because it doesn't know what miles is about. Right? It has to be declared before you can use it, and it has to be in scope. You have to see it within the context of the code that you're using here. Right? If you've got one variable in one function, and then you go over and you start developing another function, that variable exists over there. It doesn't exist over there. Right? So you have to be careful of scope, right? And that's what we call it. Both languages, for this reason, are called a statically typed language. How many people do have a Python background? Okay, so did you ever declare a variable like this? No, if you did, it would be like a syntax error. It doesn't know what int is. It doesn't know what char is. It doesn't know what double is. It just knows, you want a variable? There you go, right? You assign 5 to a variable, right? And it becomes an integer. You assign 5.5 to a variable, and it becomes a floating point number. You assign the word FIVE to a variable, and it becomes a string automatically. Those are what are called dynamically typed languages. These two are statically typed, and so you have to declare the variables. You have to declare their types before you use them. Right? And just in case you're thinking, oh, dynamic, that sounds awesome. No, it comes with its own set of headaches. believe me. Right? That we won't get into because neither of these languages is dynamic, right? All right, we'll go ahead and pick it up there on Monday. Oh, is there a way to declare a constant without having to append final? Not in Java.